we'll be doing our third demonstration of the day, States of Matter, Liquid Nitrogen. If you want to learn all about the different states of matter and see some fun with liquid nitrogen, head on down to the Daniel Cracchiolo Theater on the first floor between the Wonder Center and All About Me. We'll be starting in about 1 minute. It's a big red and gray stage. You can't miss it.
Yeah, I'm periscoping it.
What?
It's like a live broadcast. So yeah, I'm recording all of it.
Sorry? Yeah, I think just the two, but I can do that way. Yeah, I can just get it after the demo. We're about to start, so. All right, good afternoon, Arizona Science Center guests. How are you guys feeling today? Awesome. You guys ready to see some fun with liquid nitrogen? Yeah, I like your excitement right there. So my name is Peter. I'll be leading you through our explorations of the states of matter and liquid nitrogen today. And since I always like to get to know my audiences on the count of 3, can everyone shout out their names as loud as they possibly can? Think you guys can do that?
Yeah.
Yeah? You guys get to scream indoors, all right? So 1, 2, 3. Awesome. Well, nice to meet all of you guys. Now, before we get started, we're going to start off with a real quick quiz just to see what you guys know. So, who can name one of the states of matter? Anyone? Yes.
Solids.
Solids. Yes, that's one of them. What's another one?
Liquids.
Liquids. And one more. How about in the very back with the glasses? Gases. Yes, those are our 3 states of matter, which you can see here. And we're going to review what those states of matter are using our handy dandy molecule ball or Hoberman sphere. Now, normally, a very awesome plaything. Today it's going to represent a little chunk of matter. Now, matter is just, well, basically everything around us. Everything is made up of matter, whether it be the floor, tables, chairs, water. But if we imagine this little chunk of matter blown up, all these red dots, those are going to be the atoms and molecules that make up our matter. Now, if you see the ball here, all those red atoms, they're very closely packed together. There's not a lot of room for them to move. They're basically stuck where they are. If I try to punch it, my hand won't go through. It kind of hurts, so I'm not going to do that anymore. But in this state, what is our chunk of matter in? Which state is that? Solids, yes, it is a solid. So what are some examples of solids in your everyday life? Yep.
Ice.
Ice, that's a great example. How about you in the back? Tables, yeah. How about the floor? Is that a solid? Yeah, how about the chairs you're sitting on? Is that a solid? Yeah, right? Because it'd be really bad if you guys were watching my show and you guys started sinking slowly through the floor towards the center of the earth. So all of those things are solids. Now, if we take a solid like ice, which is just water in its solid form, and we add heat to it, what's going to happen? Yes? It's going to melt, yes. So when you're adding heat to an object, what you're doing is you're adding more energy to those atoms and molecules. And if you add enough heat, then those atoms and molecules really start to vibrate. And they start to move about, and they'll change states from a solid to a liquid. And now I can even stick my arm through the ball. So as liquids, these atoms and molecules, they can slip and slide all over each other, which is also a good thing if you guys like to go swimming, right? Because you want to dive into the pool and you want to make a big splash and not hit something hard. Now, if we take a liquid, like water for example again, and we add even more heat to it, what's going to happen? Yes, in the back. It's going to turn into a gas, yes! And as a gas, all those atoms and molecules, they have lots and lots of energy. They have so much energy that they really don't want to stay close to each other at all. They just want to fly all over the place, take up as much space as possible. In this state, I can even stick my head into it, which is a really good thing, right? Because everyone take a deep breath. What do you guys just breathe in? Air, right? And air is a gas. So it's a really good thing that we can take deep breaths and breathe in gases. Now, our atmosphere is made up of a number of gases, and we're going to focus on one gas today, which actually makes up almost 77% of our atmosphere. But before we get to that, real quick review. What happens now if I take a gas and take all the heat away from it? What's going to happen to it? Yes? It'll turn into a solid, just like our molecule ball. Oh, and there it goes. So, like I said, our atmosphere is made up of a number of gases, but the majority of it is made up of nitrogen. Now, like I said, when you guys took a deep breath, most of the time we find nitrogen as a gas. But today, I've got something special. I've got nitrogen in its liquid form. So I'm going to pull some out, and you can kind of see what it's doing, right? It's kind of smoking, it's bubbling, it's crackling. It almost looks like it's boiling. So, it's almost like a volcano, right? And things that are boiling or things that are like a volcano and smoking, you normally think they're hot, right? So how many guys think that liquid nitrogen is hot? Okay, I see some hands. How many guys think liquid nitrogen is cold? Some more hands. How many guys aren't sure and you just want me to give the answer? Or you didn't want to raise your hand? See, somebody's honest. All right, well, we're going to do a little experiment and find out if liquid nitrogen is really hot or really cold. And I'm going to do it using this object. Now, to many of you guys, this might look like the common domesticated house kettle, right? But today, it's going to be a very important scientific instrument. What I'm going to do is I'm going to put some liquid nitrogen into the tea kettle. Now, what normally happens when we put water in a tea kettle, set it on the stove, and let it boil? I heard it. Some of you made a whistling sound, right? It whooshes and it whistles. So let's see if the nitrogen is boiling. Wow, you guys hear all that? It's actually getting pretty loud and crazy. If I hold it still, you can kind of see some smoke and steam shooting from it. You can see some smoke or some other stuff coming off of this. So it would appear that liquid nitrogen is boiling, right? So I'm going to dump this out. And I'm going to walk around. So if you guys are in the first or second row, you guys can touch the bottom of this, but I ask that you just high five it. No longer than that. Just really quick and keep to yourself what it feels like. Don't give it away what it feels like, all right? You want to give a shot? Oh, you? There we go. Everyone. You want to give it? High five? High five. Here we go. Yes. Anyone else? All right, so on the count of 3, everyone tell me what they felt. 1, 2, 3. What? But guys, wasn't that just boiling? Wasn't it whistling? And didn't we say when we put water in there and it boils, it's really hot? So, okay. Well, it's cold. Let's try another experiment. Maybe we can see if the liquid nitrogen is really changing states. Maybe there was just something funky with our kettle, but we can actually do another test experiment and see if it is changing states from a liquid to a gas. So I'm going to take this flask and I'm going to fill it up with some liquid nitrogen. Now, what do you guys normally fill up a balloon with? Anyone?
Oxygen.
Oxygen, yeah. Air, yeah. Helium sometimes too. But those are all gases, right? So I've got a regular, ordinary, deflated balloon, and I'm going to cap this flask. And if our balloon inflates, that would mean that since the system is closed, that this liquid is changing states from a liquid to a gas, and it's filling and inflating our balloon. So let's see what happens. If I can get this balloon over the flask. Look at that. Is the balloon inflating? Is it filling up with gas? Is the liquid nitrogen changing states from a liquid to a gas? Oh my God, should I let the balloon pop? Now, today the balloon survived, although it drifted away. All right, so we've done a couple experiments, and we have determined that liquid nitrogen is boiling. It is changing states from a liquid to a gas, but it's really cold, which is kind of perplexing, right? That's not what you normally expect. Boiling things are hot, you know, not to touch like pots of boiling water. So that's a lot to think about. So we're gonna take a real quick pause for a puzzle. Now, here at the Arizona Science Center, we love puzzles. We have a whole table of puzzles there, and we've got more puzzles on the second floor. But I think this is actually the hardest puzzle we've got here. So who thinks they can beat my challenge? It's the hardest puzzle. Let's see, how about you in the red, and you with the glasses, come on up. Alright, so here's how it's gonna work. Let's see if you guys can beat this puzzle. So, I'm gonna give you this ball on a stick and this hoop. And your job is to get that ball through the hoop. Think you guys can do it? Yeah? Alright, on your mark, get set, go! What? Guys, I just told all those people this is our hardest puzzle, and you just did it like that. You just like made me look really, really bad. All right, round of applause for our volunteers. They're obviously very, very skilled at puzzles. He's giving me this like incredulous look, like, what? That was so easy. All right, that's fair. I have one more trick up my sleeve, however. I have the power of liquid nitrogen. So I'm gonna take one of these, and I'm going to stick it in the liquid nitrogen and cool it down. So which one do you guys think I should stick in the liquid nitrogen? The ball or the hoop? Show of hands. The hoop? All right, the hoop wins. So I'm gonna stick the hoop into the liquid nitrogen, and we're gonna let that cool down in that liquid. Now, while it's doing that, let's talk some more about how cold liquid nitrogen is. So, do any of you guys think we can find liquid nitrogen here on Earth naturally? Show of hands. Who thinks yes? Who thinks no? All right, so you guys are pretty smart. We actually can't find liquid nitrogen anywhere on Earth. See, where do you guys think the coldest place is on Earth? Yeah?
Antarctica.
Antarctica, yes. Very smart. Do you guys know how cold it can get down there? Or what the record temperature is? You guys take a guess. Negative 150? You're pretty close. So the coldest temperature was about negative 135 that was measured at a place called Vostok Station. Now, it turns out liquid nitrogen is even colder than that. It's about 321 degrees below zero. So 200 degrees colder than the coldest place on Earth, definitely colder than anything we can get naturally. So we're not gonna find it just laying around. We actually have to make this stuff in very special labs and factories. But there is one place in our solar system where we can find liquid nitrogen. You have a guess? That's a good guess, actually. So, Pluto, you're on the right track, is so far away from the sun that it's really, really cold there. But in fact, it's so cold in Pluto that nitrogen isn't even a liquid anymore. It turns into a solid, it freezes. So we gotta go a little bit someplace warmer. One planet in from the sun, what are we talking? Which one? What'd you say? Neptune, yes! And through the power of PowerPoint wizardry, there's Neptune, and it turns out a moon of Neptune, it's the largest moon of Neptune called Triton. There are actually lakes and rivers of liquid nitrogen on this moon. It's so cold there. But the coolest thing is, there are such things as liquid nitrogen geysers that we've seen with our satellites. So that's what I'm going to demonstrate for you next, using this handy flask. Now, if you've ever seen geysers on Earth, like Old Faithful or at Yellowstone, or anywhere else, it's very similar. It's the same effect. So what happens is a liquid like water, or in this case liquid nitrogen, collects in these little pools and crevices and cracks underground. And deep inside, of course, it's hot. There's a lot of heat from tectonic activities. And what happens is there's enough heat that the liquid eventually turns into a gas. And as gas, it builds up pressure, more and more pressure, until eventually it erupts forth in a big stream of liquid and gas. And that's what we're going to demonstrate now. So let's get a big countdown from everyone. 3, 2, 1, eruption! That was a nice big eruption. And a nice cool breeze to follow. And of course, just like geysers on Earth, it has a little mini after eruption. Unfortunately, there's not enough nitrogen in there to have another eruption. So just like on Earth, we have to wait until that refills with some more liquid to, again, build up pressure. So that was a lot of fun. But what's also fun are puzzles. So we're gonna bring up our 2 volunteers again, same volunteers, and we're gonna see if they can handle our puzzle this time. Now, same deal, 1 ball, or 1 hoop, and 1 ball. Make sure you only hold on to the wood part this time. And let's see if we can get the ball through the hoop. Mark, get set, go. See, it's a lot harder. All right, we're not gonna be able to force it, I promise you. We've had stronger people try. And it turns out, give them a round of applause because they still did a great job. through no fault of their own now, it is impossible to get this ball through the hoop. You guys can take your seats. Because if you remembered back earlier when we were talking about the different states of matter, remember as a solid, all those atoms and molecules, they're packed really closely together. But it turns out if you keep cooling down those atoms and molecules, they lose more and more energy and they stop vibrating and they get ever so closer together. Kind of like you guys, when it's really cold out, you want to huddle together for warmth. So those atoms and molecules shrunk just enough that our hoop is tiny and our ball does not fit through the hoop. And now, that brings me to the conclusion of our show, where I have a little story to tell you guys about my dog. Now, this is my dog. Fortunately, he doesn't have a name. So does anyone have a name for my dog? What's the name of my dog? How about you in the stripes?
Leroy.
What?
Leroy.
Leroy. Leroy is an excellent name for my dog. Now, my dog, not surprisingly, is very curious. He never stops wondering, a lot like us at the Arizona Science Center. So one day I brought some liquid nitrogen home thinking, you know, I could use this to make ice cream. The faster you freeze that ice cream, the smaller crystals make creamier, tastier, yummier ice cream. But as soon as I set it down, I got a frantic phone call saying, hey, you forgot to turn off the third floor, get back here. So I ran out the door, and Leroy, being the curious fellow that he was, ran over, seeing this new thing, and flew inside. And he saw this cloud of steam come out, and he thought, oh, this must be like a nice warm bath Peter made for me so I can rest my legs since I've been running around all day and they're all sore. So he dived in. And it was really unfortunate because Leroy didn't ever learn to swim for some reason. So he was trapped in the liquid nitrogen. And when I came home, well, he didn't run for me like he normally does. So I eventually found him and I pulled out his sad, mangled remains and body, and I just threw him out on the floor. I ran into a corner, cried, oh my God, I'm the worst dog owner in the world, what happened? And then eventually, when I came forth for my morning, I found that Leroy had magically come back to life. Yay! Yes, round of applause for Leroy. So, what do you guys think happened? How did Leroy survive his trip through the nitrogen? Yes? Exactly, yes, he's right on the right track. So, remember our different states of matter here, and like any good balloon animal, Leroy is filled up with a gas. So when I stuck him into the liquid nitrogen, all those gas molecules, they lost their energy, they cooled down, they changed states from a gas to a liquid, and as a liquid he had no pressure, so he basically shriveled up. And then when we brought him back out into a relatively toasty atmosphere, about 75 degrees, then all those molecules, they gained their energy back, they changed states from a liquid to a gas, and Leroy came back and he survived. And so now, I should probably give him away to the person who named him since I'm a terrible dog owner. And that concludes my show, everyone. I've got some liquid nitrogen left, so you guys stick around. I'll do another geyser. But otherwise, thank you for being such an awesome audience, and enjoy the rest of your day at the Arizona Science Center.